Ich gehe in Zoom und konzentriere mich jetzt ausschließlich auf Zoom. We are.
Ganz, ganz herzlich willkommen. Ich sehe eine volle Planetariumsgruppe und es ist der 5. Juli und das ist ein Termin, auf den wir lange hingearbeitet haben. Wenn ich so zurückdenke,
Der Übersetzer ist nicht da.
das über 2 Jahre gewesen.
And it was more than 2 years since my colleagues and the artistic director of the Dresdner Sinfoniker Orchestra devised the first artistic concepts for what expects you tonight. We're taking you along for the sound of the universe. And what we are planning tonight is one of the most complex things, maybe it is the most complex thing, which the Planetarium in Bochum has ever witnessed in a history of almost 60 years. We have musicians from Jaipur in India, we have musicians of the Dresdner Sinfoniker Orchestra are playing music together. We have colleagues dialing in from Alexandria, Egypt. So we plan something special.
Ja, herzlichen Dank für die Einladung hier nach Bochum.
Thank you very much to the invitation to Bochum Planetarium. My name is Andreas Gundlach. I've been a member of the Dresdner Sinfoniker Orchestra for more than 25 years, and we have a small ensemble of this orchestra here with us tonight. I'm looking forward to the music, which hopefully will be a success. Music which inspires or is inspired by the insights into our universe, celestial bodies and frequencies. Frequencies we want to make audible. And the special thing is, Susanne, you said it, when we deal with astronomy, we deal with large distances, both in space as well as in time. And we can bridge these gaps. We have a live connection to Jaipur in India, to Alexandria in India, and we also connect the antiquity of astronomy and the classical period of astronomy with modern times of astronomy here in Bochum. And the music we're going to play will be completely improvised. So the orchestra is not playing sheet music, but we will have to listen very closely to what our colleagues in India are playing and how we can place our sounds into it. And I would also like to welcome all the listeners, viewers on the internet who have a live stream on YouTube. Acoustically, you always hear both ensembles playing together, and we also showed as much as possible here on the dome. I'm moving to the musical instrument and we're going to say something about safety. Exactly. Because this is a planetarium. And that means that we've heard about the complex preparations and we've dealt a lot with light. A planetarium works because it's dark, and the Dresden Symphony Orchestra needs some light to be able to play, and we're going to give it to them. However, it will be so dark as possible, as dark as possible, so that you see that something's happening on the dome. It's a star travel with our star projector, taking us through time, through the night, to another time zone of Alexandria and Jaipur. It's also a travel across the planet, and it's a travel into the universe. And to make it visible, we can't have too much light. And therefore, the typical rule applies. You can leave any time, but unfortunately we cannot let you in again. Because otherwise you may stumble or fall over your neighbor looking for your place. This is what we want to avoid, so we have to take that seriously. But please relax. You can recline the seat rests, so many are already reclined. There is a button on the right side, and of course the inclination is a lot at the front and not so much at the back. And we ask you, with the electronic devices you have, smartphones, we don't want to see them, we don't want to hear them. Because imagery and music, that's not the job of your electronic devices. So please switch them off if you can, but it's okay if you just mute them and put them in your pocket. Another thing, Andreas just said that our Indian colleagues, our Indian musicians are always with us. They always keep playing with us. And we often see them on the dome, but we don't always see them on the dome. Even if we don't see them, they are with us. This is due to the fact that there are some parts of the presentation where we want to focus on the imagery covering the whole dome from the universe. But even if you don't see the Indian musicians, they're there and they are playing. And on that note, I wish all of us a great evening.
Herzlich willkommen
zu unserem
Traumflug durch das Weltall. Wir sind ganz herzlich auch eingeladen.
The flight through space after the music. You are very welcome to bridge the gap between two inputs with an applause, and that's the right time.
Und ihr Klatschen ist genau der Antrieb, den wir brauchen, um jetzt nach
exactly
Indien zu kommen.
The drive we need to propel ourselves to India, to our friend Vinod Joshi, and who's going to report a bit about tradition there.
Thank you. Namaste and good evening from Jaipur, the beautiful pink city of India and the city of Jantar Mantar. Welcome everyone joining us from across the world. The project has been a rare and the beautiful coming together of music, science and storytelling. We are truly honored to be part of it. It has allowed us to cross borders and disciplines and to explore the universe not just through science but through emotion, sound and shared curiosity. On behalf of our entire team, I extend a heartfelt thanks to my dear friend, Mr. Marcus, Artistic Director of Dresdner Sinfoniker. His initiative has brought us into this circle of collaboration. A very special thanks to Mr. Benjamin, the creative and technical force behind this project. Ben, your clarity of vision, patience, and eye for detail have truly held this entire team together. We are grateful to Ms. Therese, Program Director of the Dresdner Sinfoniker, to Professor Dr. Suzanne of Planetarium Bochum, and to the team Alexandria, and to Dr. Alok Pandya, our scientist from Jaipur. Speaking of Jaipur, it is a beautiful plant city founded around 300 years ago by Maharaja Jai Singh II. A shining example of our legacy is the Jantar Mantar, an 18th century astronomical observatory that still stands today as a marvel of human precision and imagination. It feels especially meaningful to now present a short introductory film on Jantar Mantar and then followed by our traditional folk musicians, the Manganiyar Ensemble. Can we play the video, please?
Jaipur, the pink city of India, a land known for its royalty, art, culture, town planning, and scientific advancements. In the heart of this historic city stands this marvel of science and architecture, Jantar Mantar, an astronomical observatory built in 1734. Jantar Mantar was designed by Maharaja Savai Jai Singh II, the founder of Jaipur and a visionary ruler with a profound interest in astronomy and mathematics. He built 5 such observatories across India. And Jaipur's Jantar Mantar is the largest and most advanced of them all. This observatory contains 20 fixed instruments, each one a monumental masonry version of traditional tools used to study the celestial sphere. These instruments were built to measure time, track stars, and observe planetary movements, all with the naked eye. The most striking instrument is the Samrat Yantra, the world's largest stone sundial. It stands 27 meters tall, and with its massive triangular structure, it can measure local time with an accuracy of about 2 seconds. Another fascinating structure is the Jai Prakash Yantra, a set of hollow hemispheres inlaid with marble slabs. It is used to determine the position of celestial bodies and to trace the solar trajectory across the ecliptic plane. The Rama Yantra, with its open circular structures, pillars, and calibrated scales, is designed to measure the altitude and angle, the angular coordinates of celestial objects. Each instrument here demonstrates advanced astronomical knowledge fused with bold and innovative architecture. They show just how far scientific understanding had progressed during that era. Jantar Mantar is not merely a collection of ancient instruments, it is a tranquil and captivating monument that continues to inspire astronomers, archaeologists, and curious visitors alike. In recognition of its scientific brilliance and historical importance, UNESCO declared it a World Heritage Site in 2010. Today, Jantar Mantar stands as a remarkable example of how science, observation, and innovation shaped India's history and deepened our understanding of the cosmos.
this wonderful, beautiful music from our traditional Manganiyar Ensemble. Now I'm going to hand over to Alexandria, to dear Faris. Over to Faris. Thank you.
Thank you, Vinod, for your wonderful music. And hello, everyone, and warming welcome from Alexandria. My name is Faris El-Ghabi, and I will be with you today from Alexandria, Egypt. Today, I will take you on a journey through time, exploring the incredible libraries of Alexandria. From the ancient wonders in all to the modern marvels that carry on their legacy. But we can't speak about Alexandria's library without speaking about Alexandria. Alexandria was founded in 331 before Common Era, which make it nearly 2,350 years old today. But how does the story begin? Let's see together.
The dawn of history, Egypt has been the land of civilizations. On its territory more than 2,000 years ago, the city of Alexandria came to life.
Alexandria was the greatest city the Western world had ever seen. It's probably here that the word cosmopolitan realized its true meaning of a citizen, not just of a nation, but of the cosmos.
Here, in this city, the ancient library embraced the best creations of the human mind and became the beacon of knowledge. And although it was destroyed around 1600 years ago, its memory continued to be a source of inspiration and a model of knowledge and excellence to scientists, intellectuals, and researchers from all over the world.
Alexandria was founded in 331 before Common Era by Alexander the Great. The city meant to carry his name and fulfill his dream. Sadly, Alexander died before seeing it completed. It quickly rose to become the heart of ancient culture and learning, famous for its great library and the legendary Pharos Lighthouse, one of the 7 wonders of the ancient world, and the 1,200 meters long heptastadion causeway helped Alexandria to establish a very secure harbor, which make Alexandria the greatest treasure of knowledge in the ancient world. Regarding old library found around 285 before Common Era, under Ptolemy I. The Great Library of Alexandria aimed to gather all human knowledge in one place, raising Alexander's original dream. He started to invite scientists and scholars to live in Alexandria on his expenses to help the library to grow. But the real growth was under Ptolemy III. The collection expanded greatly. Ships arrived at the port had to surrender their books to be copied, and he sent agents worldwide to search for books and scrolls. After the huge number of scrolls and books, it was hard to search on exact one, until the scholar Callimachus gave us a solution. He created a huge catalog of 120 volumes, known as Penix, to organize this enormous collection. Through ages, Alexandria Library opened its arms to all types of science and scientists. I will now introduce 2 attractive brilliant minds. First, Heron of Alexandria invented early steam power device and coin-operated machines, which we are using right now worldwide. We can't be in an astronomy event without mentioning Eratosthenes. He was a mathematician, astronomer, and geographer, the knowledge which helped him to be a manager of Alexandria Library for 40 years. He read in a scroll in Alexandria Library that on the 21st of June at 12 o'clock every year, there is a well in Aswan, an Egyptian city, fully lighted by sun rays, which mean the sun is perpendicular on the well. But he found in same time and date, we can find a shadow for an obelisk in Alexandria. This was the first proof that our earth is not flat. Then he started to calculate the distance between Aswan and Alexandria and the shadow angle of the obelisk in Alexandria. With using simple mathematical equation, he could calculate Earth's circumference. Unfortunately, due to several invasions, the old library burned. In modern time, Egypt revives this incredible heritage.
العالم كله عارف عنها.
It is one of the places in the world that you want to be at.
I think that the bibliothèque is absolutely one of the beacons of enlightenment.
Is a treasure not only of Egypt, but of all of mankind.
It's the dream of all scientists.
I think it's a symbol of knowledge.
That's the way libraries should be.
It's a paradise.
Oh my goodness, this is where my research has to be.
Bibliotheca Alexandrina opened in 2002, built close to the site of ancient library. It continues the spirit of learning and sharing knowledge. The Bibliotheca includes specialized libraries, museum, exhibitions, a planetarium, and a large conference center to serve visitors from around the world. Today, Bibliotheca Alexandrina, where I am standing right now, holds around 2 million books and had capacity for up to 8 million volumes, make it one of the largest libraries in the Middle East and Africa. And now, let's go to Planetarium of Bibliotheca Alexandrina.
To consolidate the role of science in society and support the spirit of discovery and research, the Planetarium Science Center was established, providing diverse scientific activities and events with the purpose of encouraging the love of science, discovery, and innovation. Visitors to the Planetarium Science Center enjoy interesting and impressive shows through which they're introduced to the wonders of astronomy. The PSC has also successfully produced films specifically for planetariums.
The Library of Alexandria, both ancient and modern, remind us of an amazing human quest for knowledge. They stand as a symbol of learning, culture, and progress. Thank you so much for listening. I hope you enjoyed this brief stop in Alexandria. Now, I will hand over the microphone to Manganiyar to enjoy the music. Small goodbye until we meet again. Bye.
Kamera. Bis auf Zack.
Ja, zurück in Europa,
back
zurück
to Europe,
in Bochum.
Back to Bochum.
Wenn man, wie wir als Musiker, eine Einladung hat in eine
you have an
fremde
invitation, like we
dann
get as
weiß man
musicians,
zunächst immerhin,
to
was man ins
another
Navi
city,
einzugeben hat.
you know what to enter into
Aber
the
die
GPS,
Schönheit und die Bedeutung der
but
Stadt erschließt sich
the beauty
erst, wenn man dort
and the depth of the
ankommt,
city will only
wenn man Menschen
open up
trifft,
to
die
you
einem die
when you are
Stadt
there,
näher
when you
bringen.
meet people
Und
who
für
can
uns waren die
explain
letzten 3
the city
Tage
to you.
sehr, sehr
And for
gewinnbringend
us,
hier in
what was
Bochum
very instructive
durch die
is to
freundschaftliche
be
Art
in
von
Bochum
Susanne Hüttemeister,
with the friendly support of Susanne Hüttemeister,
Leiterin des
who is
Planetariums.
the director
Und
of
sie
the
weiß
Planetarium.
unglaublich viel zu erzählen über das
She knows so
Planetarium,
much
über
about the
Bochum.
Planetarium, about Bochum,
Und ja, wir sind sehr gespannt,
and we're looking forward
was du uns
to
zu erzählen
what you
hast,
have to
Susanne.
share with us, Susanne.
Planetarium und stehen ein bisschen
So we're
für
in the
die
Bochum
Neuzeit.
Planetarium, and in this triad we stand for the modern times of astronomy, after antiquity and the classical period. Since 1964, our planetarium stands on a little hill for more than 60 years now, close to the city park and also close to Bochum downtown. There's hardly any modern view of Bochum where you don't see the planetarium. Over the past 6 decades, it has become a true landmark in the cityscape. And this is not only due to the architecture, which is protected, but it leads us to Bochum's modern history, which is very much always a story of transformation, not always without challenges. It all began at the dawn of the space age. In 1957, when the first satellite was launched, the Sputnik, there was a former Navy radio operator living in Bochum, Heinz Kaminski, and he was one of the first people to receive the signals with very simple means. This, however, made him a very famous person. And his fame facilitated the formation of a Bochum Institute for Space Research. And his influence on the politicians in town allowed him to open the planetarium in 1960. Well, it was the time of the resolution was adopted in 1962. The groundbreaking ceremony took place, and then construction progressed rapidly. The foundation was also closely tied to the structural transformation facing the Ruhr region and Bochum. Already in the 1950s, the coal mines began to shut down. Coal mining, which was so important to Bochum, was dying. And the city turned its focus to other things, such as research, science and education. Not only the planetarium was founded, but in the same year, Ruhr University, Bochum, was founded, today one of the largest universities in Germany. And in November 1964, the planetarium was officially opened. So 2 years of construction, I think it would take longer today. Already in its early years, the planetarium attracted just under 100,000 visitors annually. Well, today it is 300,000 per year, but even the 100,000 were such a great success that the planetarium became an indispensable part of the city. In the first decades, obviously, all shows were operated live from a central control desk. And also the starry sky, the movement of the planets was always explained live and in real time. This reflected the original concept of the projection planetarium, which exactly 100 years ago was first opened in Munich in 1925. This was the first planetarium of the world, opening its doors for public shows. And by the way, this is one of the occasions we are here for tonight because we are commemorating this 100th anniversary of the planetarium as such. On the Bochum Dome, we quite early got the first computer monitors. We've always been open to innovation, but some things which happened in Bochum, like this fashion show in 1967, which was about the world in the year 2000. You know, that's what they thought, what people would dress like in the year 2000, 25 years ago. Well, oh well, in retrospect, that wasn't very realistic. By the end of 1970, however, we had the 500,000th visitor welcomed here. And in 1976, the number had reached already 1 million. A young visitor is here congratulated in front of a large globe, which you can still see at the periphery in the foyer of the planetarium. Our star projector, which was in service from 1964 to 1999, became more and more automated over time. But in the year 2000, it had to be replaced. It was replaced by the one you still see here, and which you have already seen in action. This is a fiber optical projector which produces much more brilliant projections. This is the most beautiful sky of the area because it's not only the clouds which block your view, but it's also the light, the artificial light, so it never gets really dark here. So the star projector was refurbished many times, modernized since the year 2000, and it still is in place. But more than 60 slide projectors had to be retired in 2010. They were filling the dome with images of nebulae, galaxies, and was replaced by our first full dome projection system. It fills the dome, and we've seen that several times tonight already, with a moving video image. And that makes the presentation far more flexible, like what we can do tonight. In addition to astronomy, the program also includes concerts and so many other events. That has become possible. Sometimes we even have dinosaurs visiting us. Or the planetarium hill fills with thousands of people because in the middle of the summer there is a lunar eclipse. But it's rarely as innovative as it is tonight. Where under the dome we have the Dresdner Sinfoniker Orchestra playing together with the ensemble from India, and where the colleagues in Alexandria in India and also here are explaining phenomena of the universe, of the cosmos, having to do with music and sound, sounds of the universe. And that across continents, I think this is one of the events here under the dome, which will certainly be a highlight in the 60 years of history of the planetarium. And this is really a highlight.
Professor of Physics in the Central University at Amarkantak here in India. I study and explore astrophysics along with quantum physics. I'm going to speak about pulsars, the pulsating stars. There is no copyright of humans on musical creations. Nature also composes some of the finest musical frequencies. Some of these sounds emanate from the stars known as pulsars. Are they musings by divine, the unknown? We never know. Pulsars are the pulsating stars that often mesmerize us with their wonderful music. The sounds of pulsars directly correspond to the radio waves emitted by some of the brightest stars in the sky. They are often detected and recorded by some of the finest radio telescopes around the world. These radio signals, when converted into audio or the sound waves, they are really amusing. Sometimes these sounds like a dawn chorus of chirping birds. Sometimes it sounds like a strange drum of tribals. Sometimes it sounds like sweet, intense whistles. Astronomers say pulsar is a condensed star that is highly magnetized neutron star, which has typically a radius of 10 to 15 kilometers. Thus, it has mass greater than a sun, which has a radius of approximately 1 million kilometers. Radiations are beamed out along the magnetic poles of the star. These pulses of radiations are received as the beam crosses the earth in the same manner as the beam from a lighthouse causes flashes. Since pulsars are rapidly rotating neutron stars, when they spin at a very consistent rate with consistent periodicity, the emitted radio waves and the corresponding audible waves give us a harmonious feeling. That is how it appears musical. By now, scientists have ascertained several pulsars categorically. Musical sounds that we listen here are recordings by NASA. Our musicians just recreate it. Some of the well-known pulsars are as follows. Vela pulsar, or what we call PSR, B083345. This pulsar lies near the center of Vela supernovae remnant. Supernovae are the newborn stars, that is a stage of an infant star. The remnant of Vela supernovae had been the cradles of massive stars that were born 10,000 years ago. Thus, Vela pulsar is the collapse core of that star. It rotates periodically 89 million seconds. Crab pulsar, or PSR B0531 plus 21. This is the youngest known pulsar, which lies at the center of Crab nebulae. Nebulae are the clouds of dust, gas, and highly compressed matter. This supernovae explosion was witnessed by Europeans and Chinese in the year 1054 AD. Pulsar PSR J04374315. This is recently discovered millisecond pulsar, which is born out of spinning off accretion material from a binary star. Binary stars are the pair of stars where one star moves around the other one and sometimes around the center of mass of the system. It rotates about 174 times per second. Pulsar PSR B1937 plus 21. This is the fastest known pulsar, which is rotating about 642 times per second. The surface of this star is moving at about 1/7 of the speed of light. The speed of light is about 30 million kilometers per second, such that its components don't fly away due to the centrifugal force during the rotation. It's interesting to note that the millisecond pulsar can be a group of many such stars, and the frequencies that we heard are the layered effects of all of them. we now listen to the natural frequencies of pulsars, and it will be followed by the recreation of these sounds by our musicians. Over to our musicians. Thank you.
Manche Dinge entsprechen nicht unserer Hörgewohnheit. Die Hörgewohnheit bildet sich natürlich im Laufe unseres Lebens aus.
Our oral habits are formed during our lives. within the sound spectrum our ears can hear, but mostly because physical conditions on our Earth are the way they are. As a matter of fact, different physical conditions apply on other planets, and that is why you can perceive different sounds. And this is what we're going to hear about from the astronomer Faris El-Gharabli from Alexandria.
It was an amazing performance, and thank you for handing over to me, Andreas. Hello everyone, and welcome again from Planetarium Alexandria. Today I will take you on a scientific exploration of the sound of the planets. If we check our solar system, we can find a lot of planets, but today we will speak about Mars, Jupiter, and Saturn. But before we speak about sound of planets, let's agree on that our space is a near perfect vacuum, no air. Our traditional acoustic waves like our sounds can't propagate through it, but our spacecraft could collect another type of data, like plasma vibrations, electromagnetic waves, and atmospheric pressure changes. Scientists started to collect this data and to transform it to something that we can hear using some techniques such as fast Fourier transform and frequency scaling, and this process called sonification. Think of it like turning our heartbeats into pips on a heart monitor that we can find in hospitals. And now, let's go to our first destination, the closest neighbor to Earth, the red planet, Mars. On Mars, thanks to Perseverance rover, we recorded real acoustic sounds in a very rich carbon dioxide atmosphere. These acoustic waves affected by low density and pressure atmosphere of Mars. And because our sound moves by vibrating particles in air, the low density will increase the space between particles, which will make our sound more quiet and deep on Mars. Scientists use filters, models to clean up these sounds, so we can listen how is the sound look like on Mars. It's comparison together the sound on Mars on Earth. Next, let's fly to Jupiter, the largest planet in our solar system. Jupiter is a giant ball of gas with a very strong magnetic field. It doesn't have a solid surface, so we can't record normal sound. Jupiter's magnetic field captures charged particles and creates a powerful radio waves. In 1979, the Voyager spacecraft heard these radio waves for the first time. But to collect more accurate data, we sent Juno in 2016, which described for us a very important process called cyclotron maser instability, which produces bursts of radio energy. This burst changes with the movement of Jupiter's moon Io and the solar wind from the sun. By listening to these radio signals, scientists study Jupiter's space weather and magnetic shield. And now, let's listen together to the sound outside Jupiter. Happens due to the supersonic solar wind is heated and slowed by Jupiter's magnetosphere. Now, let's travel to our final destination, Saturn, the planet famous for its beautiful rings. Like Jupiter, Saturn has a strong magnetic field, which creates powerful radio waves near its poles. The Cassini spacecraft from 2004 to 2017 studied Saturn in great details and discovered that Saturn polar regions have auroras, similar to our northern and southern light on Earth. Near these auroras, Saturn produces aurora kilometric radiations. These aurora kilometric radiation comes from charged particles moving along magnetic field lines, creating complex radio signals. When scientists turn these signals into sound, they heard pattern connected to Saturn's magnetic activities. And now let's listen how does the sound look like outside Saturn. Thank you for exploring the sound of planets with me today. Sound truly connects us across space and cultures. Now, please enjoy the beautiful music from Bochum. And remember, we are waiting for you in Alexandria at the Planetarium to keep discovering together. And now, I will hand over again to enjoy the performance of sounds of planets.
Wir starten jetzt hier in Bochum ein kleines musikalisches Experiment.
Bochum, we're going to start a little experiment, very much in the sense of the tones, sounds of planets. If you imagine that every planet in our solar system is circulating around the sun, this is a vibration, albeit very slow. This is a frequency which is so low that I would need a piano which is several meters wide. It is 50 octaves in depth. But these are specific sonic levels. We've heard about Mars and Saturn. They correspond to a D on my keyboard. Or Jupiter corresponds to F sharp. Venus corresponds to A. And amazingly, in our solar system, there is real harmony which is created by Earth with the C sharp. This is a little tender, a little fragile, and these calculated tones of our solar system will be the material for our improvisation now.
Frau Professorin Susanne Hüttemeister hat ja auch eine Professur an der
also teaches as a professor at Ruhr University in addition to her position being the director of the planetarium. And I've already heard a lot from her about the difference between astronomy and astrophysics, because there is none. So it's the same thing. However, for 100 years, there has been much more insight, and I'm looking forward to your input, Susanne, on astrophysics.
Ganzes, dann wären wir noch ein bisschen länger hier. Aber über die Astrophysik
so much more,
von ganz besonderen
but we are focusing on the astrophysics of some particularly bizarre objects, and that's the black holes. And this is the attempt to make them heard, and that brings us back to music. Black holes may be the most mysterious objects we know in the universe. They've been called points of no return, places where gravity is so strong that not even light can escape. But if you think about it, how is that possible? Light doesn't have mass, it's not heavy. So how can gravity keep light from escaping from a black hole? The simulated image of a black hole against the backdrop of the Milky Way gives us a clue. At the center, we just see darkness, but around it, the Milky Way appears strangely distorted. The reason is that the gravity of the black hole is bending space itself. Basically, every heavy body does that, even our Earth. And the way you can imagine is that Earth is on a rubber mat, and there you see a little dent, and this is where the moon is circulating around the Earth. With a black hole, the principle is the same. However, our dent has become a bottomless funnel. If matter gets too close, it will cross something which we call the event horizon and falls inside the black hole irrevocably. And the same happens to light. Because light as well must follow the curved paths of space, and therefore, beyond the event horizon, there's no way out. However, the area just outside a black hole can sometimes shine more brightly than anything else in the universe. The reason is that matter, before it disappears, heats up, gets really hot, and therefore radiates very strongly. And then you see a disk forming, and although it may be thin, we perceive that as a very distorted object, because we even get light from the back side, because even the disk and the light in the disk has to follow the curved shape. Sometimes a black hole isn't alone, but it may be accompanied by a normal star. Maybe 10 times as heavy as the sun is accompanied by a blue hot star. And the black hole sucks in gas from the surface of this star. It ends up in the disk, and it produces not only light but also a jet, which consists of hot gas and is propelled far into space. And the same happens at a much larger scale. In the centers of galaxies, also in our Milky Galaxy, there are supermass black holes, which may be 1,000,000 times, even 1,000,000,000 times heavier, with more mass than our Sun. And these disks are 1,000,000,000 times heavier and brighter than the disk around such a small stellar hole. They consist of gas, maybe clouds drifting between the stars, or even of stars that have been ripped apart by gravity. That also happens. These disks and jets can contain enormous amounts of energy and therefore be 1 billion times brighter than our sun. Such a black hole can also be found in a galaxy which is at the center of a cluster of more than 1,000 galaxies in the Perseus complex, 250 million light years away. The black hole has about 800 million times the mass of the Sun. The cluster contains many galaxies, but this central one stands out because it doesn't only shine, with the starry light, but it also emits hot gas. And it is shining in X-rays, not only in this galaxy, but also in the intergalactic space, across hundreds of thousands of light years. And within this gas, the energy which is released near the black hole creates expanding bubbles. It's like waves, and thanks to image processing, you can see them here. And they are easily visible. These are denser sections of the gas which are slowly expanding. And denser and less dense regions in the gas are sound waves. These are tones. And it may be even the basis of music. However, sound waves are very low. Now, we've heard about 50 octaves for the planets. Unfortunately, that's not enough. 57 to 58 octaves below the range of human hearing. Or that's a factor of roughly 200 quadrillion. It's 1 followed by 15 zeros. So between one wave crest and the next, some 10 million years pass. But we can shift these tones into the audible range. And then follow them from the inside out. What that sounds like. So this actual sound, well, yes, it is translated, and of course it is elevated, which really comes from a black hole, has been calculated by NASA, and they simulated it. And let's hear what the musicians make of this sound material. First, we'll hear the original sound. I'm looking for that. Wir fangen an mit den Musikern in Indien. Der Klang des schwarzen Lochs. Und dann wird improvisiert. With that, we've reached the end of our interstellar acoustic journey. Thank you so much for joining us here. Thank you to all the viewers on YouTube. We've really enjoyed being here. Thank you to the team of the Planetarium. Let me mention Professor Susanne Hüttemeister and Tobias Wiethoff. He was in charge of projection, and of course the whole team. I'm not sure if you understand that what we have been presenting here is enormously more difficult than just FaceTiming or WhatsApping your family. You have sound and image from 3 places going to 3 places is a massive technical challenge which has been mastered here, and I would like you to give them a big hand. I may
vielleicht noch kurz vorstellen.
just shortly introduce at the violin Ellie the fiddle.
Am Schlagzeug
On percussion Stefan Emich.
Am Bass
Bass Tom Götze.
Mein Name ist Andreas
My name is
Gundler.
Andreas Gundler.